and these are the wave question. First let me give you a little bit explanation. So diffraction gradient equation is d sine theta and wavelength multiplied by the wavelength. Okay, d sine theta is equal to n multiplied by wavelength. Okay, so d is the, you can see d distance between the slit. Okay, here d is the distance between the slit, not this d. Okay, here in the diffraction gradient, this d is distance between the slits. Again I am repeating, this is distance between the two this slit. Okay, this is the d. And angle is the this angle. Okay, this angle, then integer n is the number of orders, right? Order 1, order 2, order 3, n is the number of order, and this is the wavelength. Okay, again I am repeating here, d is distance between the slit, this small d is the distance between this slit. Okay, and this formula is also important, n 1 by d. N is the number of slits per meter. In 1 meter how many slits are there? Okay, in 1 meter how many slits are there? This. Okay, these two formulas are very important. Okay, first you should know the formula. D means what, theta means what, n means what. Okay, and wavelength obviously they will give, or sometimes they will say to find. Okay, see here I have to do this question, I have to use two formula. Okay, so here they are saying find the number of lines per meter. It means they are asking then n, capital N. Okay, so it's 1 by d. So obviously first you have to solve this, find d here if d is not given, right? Okay, so one more thing you have to remember, this one, incident normally means sine, here sine theta is 90 degree. What? 90 degree or 1 you can take. Sine theta is 90 degree. In calculator check what is the sine theta. Okay, incident normally means sine theta is 90 degree, not n is 1 or 2. Okay, again I'm repeating, not n is 1 or 2. Okay, here this is sine theta is 90 degree. Okay, incident normally means sine theta is 90 degree. Okay, now sine theta is 90 degree. We got wavelength, we have this wavelength is there, you can see, and now wavelength is there, then this d is there. Okay, this d is there, 165. Okay, then okay, so here in this question, this is the big D. Okay, this is not a small d. Okay, here you have to find the d. As I said, here d is the distance between this distance. Okay, so here what they are saying, what are the things given. First you will write what are the things given. Okay, so the things, wavelength wavelength is there, and this incident normally means sine is 90 degree, and this one, this big D is there, distance between the slit and the screen is there. Okay, so now we have to find angle. Okay, we have to find angle. So how we will find the angle? is we will use this formula, tan theta opposite by adjacent. So at this angle, this full distance is given, this is 76, so we have to from the P. So how much is the this distance? So we know this is 65. Why they give you this distance, the capital T? Because so that you can find this angle, you can find this angle. Okay, because in order to solve this question, I mean right angle triangle, you have to solve this angle. Okay, so you have this 165, you know this full is 76 and half is 38, so you can get very easily, you can get. So why do we need this angle? In order to get D, we need this angle. Okay, now we got D is equal to D is n multiply by this and sine theta, and this is order 1. This is the first order, right? This is the first order, that's why we took n is 1. This is the first order, that's why we took n. This is the first order, then it will become second order, that's why we take n is 1, and then multiply by wavelength is the so 10 raised to minus 9, and angle is we got sine 13. So what angle we got, that is sine 13. So we got D. So when you got D, very easily you can find n is equal to 1 by D. So n is equal to what? N by D. So 1 divided by this, you got the answer here. Okay, again I am repeating, first you should know the formula. D is the this distance, okay, between the slit, okay, from to here. So angle, this angle, okay, integer is a number of the orders, first order, second order, third order, okay, like this. And here wavelength is the wavelength they will give you, right? Just you have to change into meters, they will give you nanometer, micrometer, so you have to change into meter. So let's see this question. This is May June 2023. Okay, again okay, let me talk about this formula. Okay, Young's double slit experiment. Okay, there's one more formula. This is wavelength AX divided by D. So A is what is A? A is the so A is distance between the center of the slit. A is what? Distance between the center of the slit. Okay, and what is X? X is the fringe. You can see X is the fringe, this fringe. Okay, this distance, this. Okay, this is X. Okay, so X is the distance between successive bright fringes. Okay, this is one bright fringe. Okay, this is one between this and this will be the your distance. This is called X. Okay, then here the wavelength, obviously they will give you here, there's a wavelength distance. Now here big D means this distance, okay, distance between the double slit, this double slit, this distance, this is the big D here. Okay, this is the big D. Okay, so don't get confused. Again, A is the distance between the center of the slit, this distance, and between the center of this distance. Okay, A, this is A. Here in the formula also you can see, in the question they give you, see A, you can see A, this is the slit and this is the distance, this distance, and this distance is the A. This is called A, this is called A. Okay, so don't get confused. Here this D is the distance between this slit and the screen. Okay, so here again you might be thinking, okay, this d is here, this d is this. Okay, distance between the slits. Okay, not this distance, this d is not this distance. Okay, this is diffraction gradient equation. Okay, this is diffraction gradient equation, and this Young double slit equation. Okay, so these two formula are very important to solve this kind of question. Okay, so here in this question you can see, so they have given you d, they have given you wavelengths, and they will say to find something, right? They are saying calculate the separation of the slit. So it means what? Separation of the slit means what? A. It means what? Slit separation they are saying. So that is they are saying to find. So in order to solve this question, you need wavelength and distance. Okay, distance you have, and also here you need x. So how to find x? X is what? The fringe, one fringe, two distance between two bright fringe, distance between two bright fringe. Okay, so here now you can see here, now they have given you so many bright fringe and dark fringe. Okay, so they have given you so many bright fringe and dark. So how many bright fringe are there? So 1 2 3 4 5 6 7 8 9 10. Okay, whatever is they have they wrote here, there are 8. Okay, they wrote here there are sorry, here see here in this they wrote here there are 8 fringes. Okay, so between two bright fringes, what will be the we need that answer. Okay, what will be the distance between two bright fringes? So when 8 is 22, when 8 fringes, when 8 fringes is equal to 32 distance, what will be the one fringe? So this you have to, so cross multiply and get the answer. Again I am repeating here, they try to make you confused. We need distance between two bright fringes means 1. Okay, you can say 1. Okay, so if 8 bright fringes is 22 meter, 1 bright fringes will be how much? So this you can do it. Okay, just divide 22 divide by 8 is 2.75. so you use here 2.75, and just it was in millimeter, that's why I have to change into meter. So 10 raised to minus 3, and you will get your answer. So this question, May June 22, question number 5. So here you can see d is given, wavelength is given, a is given, so very easily you can solve this question. So what they are finding, they are saying to find x. Okay, distance between two bright fringe, right? X is distance between two bright fringe. So just write the value and just solve it. Here very easy question, nothing to do. Okay, here just you have to change wavelength nanometer into meter, 10 raised to minus 9 you multiply, and this is already in meter and this is in millimeter, 0.44, just multiply by 10 raised to minus 3. So this is May June 2021, question number 4. C, you can see everything is given, distance is given, and a is given, wavelength is given. Just they are saying to find the x, right? X, distance between two bright fringes. So just write this and you will get 3 marks. And so this is May June 2021, question number 4. Let's see what they're asking. Okay, here they have given 2 things, a, okay, and they have given you Okay, they have given you A and they have given you D. So but they did not give you what they are saying. They are saying find the wavelength. Okay, in order to find wavelength you need A, you need X. So where is X? Yeah, where is X is also here, 4.3. You can see X is here. This is 4.3 into 10 raised to minus 3, right? So everything is given, just put the value and get A is this, A is okay, is also in meter, D is you don't have to, okay, this you have to change into nanometer, right? So first solve the answer and change it into nanometer. Okay, this is May June 16 22, question number 5. Okay, see here again in this question, see here they have given angle, this full angle, but what we need from the zero order this much angle we need. This right angle triangle we need this much angle. Okay, so if they are giving you full angle, you cannot take full angle. Okay, so 59 we divide by 2, we got 29.2. So we can take this angle. In sine theta we can take this angle, we cannot take 59. 59 is the full like this they are giving you. Okay, so what does the formula say? Angle is this angle from the zero order to how much it's going up. Okay, there is first order, second order. Okay, there, so you will find only this angle. So this we will divide and 29.2. So there are two order, so two order means what? N will be 2, right? So just simply, so understand the question, what they say, number of lines per meter. Number of lines per meter means what? This one, capital N. Okay, so in order to get capital N you have to find D. Okay, so you have to find first D. So D is what I say, this D, small d is the distance between the slit. Okay, so everything is given in this. Okay, just arrange it. See here I have arranged everything here. This I have arranged everything here, you can see, and I just put the value and got the D and N. So 1 divided by D, so I did 1 divided by D. So here I put 10 raised to minus 3 to change it to millimeter, because they are saying is to change this into millimeter. So if I have to change this to millimeter, so I will multiply with 10 raised to minus 3. Again I am repeating, if I have to change this to, here they are saying number of lines per millimeter. So if they say millimeter, you will just multiply with 10 raised to minus 3. If they are saying meter, you don't have to multiply. You don't have to multiply with anything. It will be 1 by D. Okay, again I am repeating, if they are saying to change into millimeter, you will multiply with 10 raised to minus 3. Okay, just answer you will here in 1 you will write 10 raised to minus 3 and D you will write down just as it is. Okay, here is one more question. This is May June 14 to 1. Okay, so May June 14 to 1, question number 5. So here see, they will just a little bit make you try to make you confused, you know everything or not. Okay, about the formula, you know everything or not. What does the word A means, what does the word D means, which distance they are taking, which A means what, this X means what. So they will try to change. So here see, they have given you waves, they have just drawn you waves. Okay, so they will ask you something. So what does the word amplitude means? Okay, amplitude means this distance, right? Amplitude means this distance, right? Right, distance. Okay, so here so here they will ask you some question, obviously. So here they have given you, like, this is 12 depth is 12 millimeter, and they have given you this is full is 15 meter. So obviously they will say to find how much distance is this. Okay, so this very easy. 15 minus 12 is this much is 1.33. So this much is how much? 1.5 millimeter, I mean 1.5 millimeter. Okay, so they have given you some wave 1 2 3 4 5 6 wave, and that is 25 centimeter. So very easily you can calculate what is the distance of one wave. Okay, so here you can see what they are asking: amplitude, okay, and the wavelength. So very easy. So see here. So amplitude is what? 15 minus 33, that is 3a. Okay, amplitude is full amplitude is 3. Okay, difference is, and half amplitude will be what? 3 divided by 2. Now what does it mean? So in the wave I thought you this is the amplitude. Okay, this is the amplitude, right? So here they have given you full wave like this full wave like this. Okay, so we need only this distance, half. Okay, we need only half distance. So that's why whatever distance we got, that's why we are dividing with 2. Again I am repeating, the things they have given you is like these, like these, like these, like this. So if you draw a line, it become half, right? Okay, so this again, whatever number we got, 3, we have to divide by 2. So 3 is this full we got, this full is 3, we got this full is 3 millimeter, right? But we need this half. Okay, so that is 3 divided by 2 is 1.5. Okay, so amplitude we got, or the wavelength you can find very easily, that is 25. Okay, 25 centimeter changing into meter. Okay, mm, so 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 calculate the period, is 1 by t, right? The period formula is 1 by t, so very easily you can find that. Mm. So this is May June 12. Okay, question number 6 to 1. So here very easy. Again they have given you a, they have given you wavelength, they have given you d, they will say to find x. Okay, this they have given you nanometer, change into meter, 10 raised to change into meter you will multiply by 10 raised to minus 10, right? This they have given you millimeter, there you go, change into meter, just multiply by 10 raised to minus 3, right? So here just for this they are giving change. Okay, so this is October number 2023. Okay, b, question number b. Okay, so see here they are now diffraction gradient is there, order is 2. Okay, angle is 16. Okay, angles, now here don't get confused. Okay, they wrote this is 16 and this is 16. Okay, don't get confused. Now don't think that this full is 16. Okay, so in this question, see, okay, this not full is not 16. Okay, just from 0 order and to second order it is 16, right? So here they are saying to find wavelengths. Obviously the formula is 2d sine theta divided by x. So d is what d they have given you, right? Sine theta is 16, right? And x is this is not x, okay, and sorry, the formula I wrote is this is n, okay. So write your formula, first write the formula, that is d sine theta divided by this. So we have to find wavelength, right? We'll make the wavelength subject, so it will be d sine theta divided by n, number of order, okay. Okay, so d you have, right? D is given here 3.4 into 10 raised to, okay, the gradient has a line of spacing of this one 3.4 into 10 raised to 6, okay. Then the order is given 2, right? The order is 2, and sine theta is sine 16, right? So get the d. So now here see, determine the highest order. Now highest order means you cannot take n is 2. So highest means it will be sine 30, always I mean sine 90. You will remember this. If they say your highest order means it will be sine 90. It will be sine 90, right? It will be like this. From the 0 order, this is the 0 order, the angle will be 90 degrees straight. So you will take sine 90. You will take sine 90 for this. Okay. Say again, I am repeating this. In highest order, at that time they will not give you number of order. Highest order means it will be sine 90. Okay. It will. So in sine 90, how many orders are there? You will find that. So arrange the formula. Theta divided by wavelength, so there are 7 orders. There are 7 orders. So this is also very easy. October 1923, question number 5. Okay, they have given you angle they have given you, that is 51, and order is 2. Okay, so everything is given. They are saying to find the wavelength. Okay, so formula d sine theta and by wavelength, right? So here I arrange it. So wavelength is d sine theta divided by n. Okay, so here I have to find d. Now d is not given, so here they have given number of lines. A number of line means that is n. This n, right? This is n, right? Capital N. Find d. That formula is d is equal to 1 by n, right? So here I will get d. So if I get d, I can just substitute the value here and get it. So everything is given. They just want to make you a little bit confused. So please read the question. The number of lines. This is number of lines per unit length. Okay. So number of lines means what? Here I have given you number of slit per meter. It means number of slit per meter is the formula is 1 by d. So don't get confused when they say number of lines per unit length on the diffraction gradient. So don't get confused. Okay, whenever they say number of lines means that is n, capital N. Okay, so this is October number 16 question number 4. The question is, okay, everything is given. They are saying to find the differences in the distance from the x and y. Okay, this you can find. Okay, calculate the d. Calculate the d means what? So it will be a multiplied by x divided by wavelength. Okay, so a is given, x is also given. Okay, and wavelength is given here. Wavelength is also given, right? 580 nanometer. So 10 you will multiply by 10 raised to minus 9, right? 580 into 10 raised to minus 9, right? So millimeter change into meter, right? 10 raised to minus 3. This also you will multiply by 10 raised to minus 3, right? Just then solve it. Here I have solved, right? D. So this is October number 14 to question number 6. Okay, here also they are saying to find x, the distance between adjacent maxima. They are saying to find the fringe, distance between two fringe. Okay, those slit differences are, the distance between two slits are given. A is given 0.35, okay, 10 raised to minus 3 to change it to meter, and D is given 2.5 in meter, and wavelength is given here, okay, 6.3 into 10 raised to minus 7 meter. So you don't have to change even this already in meter, just write for this. They will give you 2 marks. Okay, so this is October number 1 to 12 21. Okay, October 12, question number 4. So here first order, this is n is 1, right? So here they have given you wavelength 625 into nanometer. You will change into meter. Okay, second order means n is 2. Okay, angle is given 61, right? Angle is what? 61. So sine theta is 61. To the incident direction, determine the number of lines. Number of lines means what? Capital N. Number of line means what? The n, this n. Okay, so in order to find this n, you have to find d. D is equal to 1 by n, right? So here wavelength is given, n is given 2, then what else things are given, and angle is given, sine is 61. Okay, so the formula, d sine theta n by wavelength, right? So we have to find d here. First find the d, so make d subject, so that will be n divided by wavelength by sine theta. Okay, when you get d, substitute here and get the n. Okay, so what will be the n? N will be 1 by d, right? So here one more question is here, October number 10 to 3. So here what are the things given? A is given, D is given, and wavelength is given. Definitely they will say to find x, right? They will say to find x, different distance between two bright fringes, right? So find, use the formula, right? Wavelength is equal to a x divided by d, make subject, so find, and this is given in nanometer, so you have to multiply by 10 raised to minus 9. This is given in millimeter, you have to multiply by 10 raised to minus 3. This is in meter. Okay, so this is October number 10 to 1s here. Okay, see here in this question, 0 order means theta is 90. Okay, there is little bit mistake in this question. Okay, see here now, how many orders are there? Okay, see, everything is given here. N is given, capital N. So how do you know this is capital N? Because they are saying different gradient having 650 line per millimeter. So what they are saying? They are saying a diffraction gradient having 650 lines per millimeter. It means capital N is given. Okay. And what else they are saying? Incident normally. Okay, here one more thing they are saying: incident normally. So when they are saying incident normally, sine theta is 90 degree, right? So incident normally means sine theta is 90 degree. Okay, the capital N is given, and so here what they will say you to find. um, so see here they are saying you to find numbers. What number? Numbers of orders. So they are saying to find n. How many orders are there? They are saying to find the order, determine the order of diffracted light that can be observed on each side of the zero order. So how many orders are there? So in order to find the orders, so what are the things are given? We have to find the wavelength is given is 590. So 590, you know how to change into meter. 10 you multiply by 10 raised to minus 9, right? So this is given in millimeter. Okay, this is given in millimeter, and you have to find. So this first let us find the d. D is equal to 1 by n. So d is equal to 1 by n is divide by this. When you divide this, you will get d. After getting that the d, you will use the formula. So here I have used everything together. Okay, d sine theta by d. So I took sine theta as 90. So d I just wrote this. Okay, 1 by into this I have changed it into 650 into meter. I have changed into meter. Okay, because that was in millimeter. And wavelength, this I wrote. Then I got n is 2.6. So you cannot write 2.6. So it's how many? Second order. Sorry, 2.6 is, I mean, third order, not second order. It's above 5, right? So it's third order, right? So we have to show this. So in this question also everything is given. Calculate the separation of the fridge. Separation of the fridge means x, right? So ax divided by d. A is given 0.7. Okay, 0.700. So you will change to meter, multiply by 10 raised to what? 0.70 multiplied by 10 raised to minus 3, right? So this is already in, okay, sorry, this is 3. Okay, and this is always, they give always in nanometer. You have to multiply. Okay, just do it. For this they are giving you for this they are giving you how much? I mean 3 marks. Okay, you have to change into millimeter. To change into millimeter also, change the answer into millimeter. So first find answer in meters, then the answer, after getting the answer you change into millimeter. So this is the easy way. First you change this into everything, you change into meter, right? So get the answer, that answer you just change into millimeter. Okay, or else, like, you know, if you can do one more thing, change everything into millimeter. This everything is better. First you change everything into meter, then just change into uh, first everything change to meter. Okay, okay, because this is in millimeter, this is in meter, and this is in nanometer. So it's better like you change everything into meter, then answer change into millimeter. October number 6, question number 4. Okay, paper 2. So here you can see wavelength is given. Okay, and capital N is given, and Now what they will say to find, they are saying to find, calculate the number of, or they are saying to find a small n, right? So in order to find a small n, you need, okay, d sine theta and wavelength. So you have wavelength, you have this you have to find. Okay, now d unit, yes, they have given you n, you know d is 1 by n, so you can find this like this 1 by 2, right? So sine theta is given, they said anything, um, red light, okay, so incident normally, yeah, here they said this word incident normally. Whenever they say this incident normally, it means sine theta is 90 degree, so take sine theta as now 90 degree, right? So just arrange and find d sine theta divided by wavelength is n, so d is what, d is 1 by n multiplied by sine theta is 90, and here wavelength is wavelength, you find it, okay. So here, see here it is 2.8, so still they are saying it's 2 ordered, so they are not seeing decimal, okay, okay, they are only just seeing the integer, the number, okay, they are not rounding this number. So your answer is 2.8, but they are not writing is 3, they are writing is 2, okay. So I think this is the last question of this paper. This is okay, October number 1. Okay, see here in this question, okay, the this d is given, okay, wavelength is given, this is 1.5 and this is small is 0.11, okay. So what they are saying to find, okay, so first they are saying show that the width of each slit is approximately 160 times the wavelength. So one width of the slit is 160 times the wavelength, okay, wavelength of the incident light. So first let us find the wavelength. So in order to find the wavelength, we can use this formula, because here speed is given, speed, speed of light is given, and frequency is given. So here you can see the frequency 4.8 and this one. So by using this formula I got the wavelength. So number of this there's a width of the each slit, okay, what is the width of the each slit? So in order to find the width of the each slit, so use this. So if the width of each slit, okay, is 0.110 raised to minus 3, so this one 625 places will be how many, means just show that is it 160 times. So how will show the slit gap, one slit gap is 0.1, you can see 0.1 between okay, this is 0.1, 0.10 millimeter, to change it into meter, right? So you multiply by 10 raised to minus 3. So in 625 into 10 raised to 9 meter, how many? So just cross multiply. So one slit gap is this much, so this much will be how much. Okay, this much will be, this much distance will be how much, right? This much distance will be how much. Okay, just cross multiply. Okay, just cross multiply this and you will get the answer. So see here, this here I made a mistake. Okay, so let me erase this. So here they are asking, see the question, they are asking here to read the question carefully. They are saying width of each slit is show that width of each slit is approximately 160 times the wavelength. So if one wavelength is this much, okay, in 0.1 width of the slit there will be how many wavelengths. So they are saying then how many wavelength will be there. So just show that. So I have to, if one wavelength is equal to this, in this much distance there will be how many wavelength. So I will do cross multiply. Okay, you have to understand the question. So in this much is the distance, right? This is also the distance. In wavelength there are this much distance, right? So in this distance how many wavelengths will be there? So this much. Okay, 160. So you will get the answer 160, right? Okay, this question also we did. So basically there are two formula. One is this. Okay, so you have to understand each and everything. Okay, here wavelength always they give you in nanometer, right? So you have to change into meter. Okay, the x means what, distance between two bright fringe, right? So they will give you this. Okay, if they are giving you millimeter you have to change into meter. Okay, a they ask, okay, or they give you whatever. So if they are giving you one thing, if they are giving you, if they are asking you for one thing they will give you three things, right? Something like that. So here and in this formula, you know, you have to know, they will give you they will write this number of slit per meter. Okay, so it means capital N. You have to always remember it means capital N. Number of slits per meter means it is capital N. Okay, and d is what, distance, this distance, and n is the order. This is wavelength. Okay, and theta is they will say you, sometimes they will give you angle and sometimes they will say incident normally. When they say incident normally you will take sine theta is 90 degree. Okay, so just do all the question and